So today we'll be looking at structure of a C program. All right. So as a building is made of bricks, a C program is made up of basic elements. So we have the constants, we have the variable, we have expressions, we have statement blocks, and we have function blocks. All right. So the constants, starting from the constant, a constant is a fixed value, just like the word constant. So it's something that doesn't change. All right. Example of a constant are like whole numbers or like decimal numbers. So example, number 10, like 10 is a constant, okay? 10 or whatever number, they're all constants. So they can't change. They're always like this. 10 is 10. Anywhere you see 10, it is 10. All right. Now there's another thing called variables. So variable on the other hand can be used to represent different values. So for example, now we can uh, name our variable as maybe x equal to, then give it a value. For example, we can give it a value of a constant of 10. That means anytime I'm calling x, it means I'm calling 10. So the way to call this is like saying we are assigning 10 to x, okay? So I replacing x and giving it as 10. So anytime we're calling 10 in our code, I mean, we are calling x, it means we're like calling 10, all right? So this x is a variable, and variable, from the word variable, it can change, which means even if there's 10 here, if I go down and put the same x again and put something like 20 here, it will pick the 20 and it will ignore the first 10 I called here. So variable can change, okay? So that's just it about variables. Variables is that, for example, that x that I declared. All right. So that's what variables are. So next, talking about expressions. So expression is a combination of constants, variables, operators that are used to denote computations. Example of expressions, just as the word sounds there, sets can be constant variables. So something like maybe if I say this is variable name equal to maybe something like 2 plus 3. So we have variable, we have constant, and we have operator. So this on its own like this is what we call an expression. So this is an example of how an expression looks like. Okay, so it's a computation of constants, variable, and operators. This is the plus operator. So in mathematical operators in C, arithmetic operators, we have the plus, we have the minus, the subtraction, we have the multiplication. For multiplication, we are using the asterisk as our times, not letter X. All right, we're using the asterisk key in your keyboard. Then the division, we're using the forward slash as our division sign. While the modulus, we're using the percentage as our modulus calculation. Hope you know what modulus calculation is. Let me just quickly explain that modulus aspect of. I think some people usually get confused about what modulus means. So what modulus means, just talking about remainder. So the remainder of whatever stuff you are on. If I say 7, if I say 2 modulus 2, just imagine in your mind that it means 2 divided by 2. And 2 divided by 2 is 1. It has no remainder. That means the modulus is 0. But if I do, for example, 3 modulus 2, 3 modulus 2, 3 modulus 2. So if I say how many 2 can we get in 3? We can get only 1, 2 out of 3. Then to remain only 1, right? Okay. So 3 divided by 2 will give you 1 point something. So if we can remove 2 from 3, we are left with 1. So the remainder 1 is actually the answer to this. If, for example, we have 5 here also. So if we say 5 modulus 2, from 5, we can get 2 out of it. If we take first 2, take the other 2, making 4, then we have only one more left that completes its 5, which is the remainder. That's why there's 1 here. So the answer is still 1 here. All right. So that's just what remainder is just talking about. That's what that modulus sign is talking about. Okay, next up, talking about function names. So function names and variable names as well as reserved keywords. We will look about reserved keywords later. So there are all identifiers. When we talk about identifiers, just like something like this now, this is a variable. So it's just like identifying something. So identifying this mathematical operator. Okay. So it's just like an example of what an identifier is. Also, function names is an identifier. Letting us know that this is a function. All right. And there are also other keywords which you will learn later on. So any characters or symbols that do not follow these rules are illegal in terms of using identifiers. All right, so to use identifiers, there's a rule to that. So looking at the first one, for you to call any identifier, you want to call or create your own identifier, it should be characters between A to Z, be it capital or be it small letter. Okay. So the second one, you can also use digits characters as part of the name of your identifier, but there's a condition to this. You must not start that name with with a digit number. Okay, so you can't use a number to start whatever name you want to start as your identifier. That is, if you want to name a variable name, just like I named this one as var underscore name. The underscore is actually valid. Looking at the third part, you can see underscore character is also valid. So what I wanted to say in this number 3 about digit character is that we can't start a variable name or a function name with a number. This is very wrong. We can choose to put the number after anything. So even if you put the number here, it is still right. Or even if you put the number at the end here, it is still correct. But you must not start the variable or the function name with a number. All right. So these are the three things you need to watch out for. So these are the only valid things. Anything outside these three valid things is wrong. Okay. That means even if I put something like maybe asterisk here, it is wrong in as much as it doesn't pertain to these three key laws here. All right. None of them said we can put asterisk here. So just keep that at the back of your mind. Then next, we talk about never use the reserved keywords. So we shouldn't look about many reserved keywords in C. So we shouldn't use reserved keywords or names of standard C library for our variable names. Okay. Also, or in creating our own function, because I'll soon show you how to create your own function, your own user defined function. So we can't be using some keywords like main. Again, we can't use to main in our C program. Okay, and since there's already a function, a standard function known as printf function, so I can't choose to create a function and name it the same printf name. It doesn't make any sense. Okay, so that's what this statement here is trying to let us know. So I have to use a name that is totally not within a reserved keyword in C programming or a standard name function. All right. So let's go back. Okay, going down again. Okay, now talking about this part, in C language, a statement is a complete instruction. A statement is a complete instruction ending with a semicolon. So what this is just trying to tell us is that if we have, for example, maybe if I say variable I and I give it a value of 1, then if I put a semicolon after it, this is known as a statement. So it's a statement as it is now. So any stuff you're working on, like even the return 0 that we usually use, this is also a statement. Okay, so most of the lines of C usually ends with a statement. So it usually ends with this semicolon. All right. So even our printf functions to end with that semicolon. So making each of them a statement. So now there are also groups, something called groups of statements. So groups of statements, this one is just like kind of like the main function. Let's take the main function for example. You notice whenever I want to use the main function, we always open and close curly brackets. So that curly bracket is a way of compressing all the mini statements we have inside it as a single statement. So that curly bracket to make it look as if it's the one statement. The reason we have to make sure everything looks like one statement because of that's what the C compiler approves of. So for us to really tweak it, that's why we're using the curly braces in, for example, our main function or any function you want to call. Okay. So now talking about function, now functions are the building blocks of C programs. Remember, our C program always run with the main function. So it's a major key thing. So functions are building blocks of C programs. Aside the standard C library functions, we can also create our own user-defined function, which we'll soon do that very soon. Okay. Then going down, lastly, we have okay, function type is used to signify what type of function what type of value a function is going to return after the execution. Like for example, our main function is actually an integer function, okay? Just that it's already an integer internally by default. But I also noticed that um, shell terminals doesn't see it that way. Like always forces us to use that int at the beginning part of it. So we should use that int main. But if you're using code blocks, code block won't force you to use the int main because you already assume that main is automatically an int data type. We learn about data type in the next video. So don't worry, you get to understand that very well. Data. Then within these brackets, there can be parameters in our functions within inside the bracket. That's why sometimes you may see something like void. Yeah. Actually means there can be also something inside it. So those stuff that can be inside it is what we call the arguments. Not fighting argument though. But yeah, that's just the word they chose to use here. So arguments, or you can also call it parameters. All right. So you can call it arguments, you can call it parameters. So for a function, each if you want to put multiple arguments, you always separate each of them with a comma. Okay, so we always use comma to separate each of our functions. So all these things we've explained here now, we're going to practicalize everything. I hope so. So let's see how it will work in our code editor. Okay, let's jump right in. So welcome back. We're on our code editor. So let's just do a small code of everything we'll be talking about so far. As usual, remember we always need to put our include, then put our .h file. Okay, and since you remember that each of our code always starts with our main function, always starts and ends with our main function. So main function is very, very important to be there. Right. So what I want to do is that I want to create a program that adds two values together. So that's the goal here. So I want to create a program that adds two values together. So what I will do now, I can just say main function. Okay. Then since it is two values, I can simply just do something like x equal to, let me give it a value 3, then y equal to, let's say 5. Okay, then I can say sum equal to x plus y. All right, so if you notice, I'm assigning this x to 3, assigning y as 5. So I'm in this place where I got x plus 5 is trying to say 3 plus 5 also. All right, now since we have 3 variables here, so we have to make sure we declare those variables. So let me declare it at the top. You always need to declare it at the top, very important. So and both of them I'm declaring them as integers. All right, so int x comma y comma sum. So this is one way of declaring it, or if you want to do it one by one, you'll be doing it one by one like this: int x, int y, int sum. This is still acceptable, just that it is making the code too lengthy unnecessarily. Okay, so you can just do it like this. Another way of doing it, you can just directly declare them as you are calling the variable directly like this. But if I doing it this way, it means you have to erase this first one you did at the top. So let me just comment that part. You understand? So, but best practice is not good to just do this stuff like this too often. So the first method is the best and generalized method to use. So I will leave it this way. Okay, just for you to understand how to play around with it. Okay, so we're adding two numbers. We're adding 3 and 5. So I'm going to print this. So using the printf function. So I'll say the sum of x and y is. Now I'm going to put a format specifier since I'm dealing with integer. I want to print. I'll print a decimal value, like a whole number. Always let me put my new line character there also. So comma. Then I'll put the variable name that I want it to print. So I want it to print sum. Don't forget to put that closing semicolon after the printf. Very important. So I want to print out the sum here, which will give me the addition of these two. So don't forget also the last part, our return 0. So let's run this code and see what it gives us. So you can see the sum of x and y is 8. So the percent, this specifier represents this sum. So whatever addition of this 3 plus 5 will give us about the 8 inside here in our printf. So that is where this 8 came about. Now, this is one way to do this, I would like to show you some other ways to go around the same stuff. So for example, even if I don't want to choose, I don't want to use this sum, I can still directly from here write x plus y. And if I print this out, it should still give me the same output. You can see, still give me the same output as 8. All right, so I just choose to put the sum so that I won't make this portion look complicated. So it just looks simple to write. That is just the best practice of making your code look neater, all right, and understandable. Mm, I'm looking at something now. I want you to understand something too about arithmetic operators. We're talking about arithmetic operators, so they have precedence. So just like in your primary school or secondary school, where you would have heard of something like board mass. Okay, so bracket always comes first, followed by off, followed by division, multiplication, addition, and subtraction. So that arrangement, it still works in our codes. So let's do something that relates to it. I want to do something. Let's say if I say maybe two two times, yeah. Let me put this place as sum again. So what do you think will be the output of this code? Pause the video and think about this. Okay, I believe you've paused the video and you have thought of your answer at the back of your mind. Okay, in your mind. So now let's see what it will give us. Now going back to this board mass, between our multiplication and our addition, which one comes first? You can see the multiplication came first here before addition. That's in our board mass. That means what is going to happen here in our code that is going to say 2 times x. I will know that our x is 3. So you say 2 times 3, which is 6. Then it will say 6 plus 5, which is 11. So this should output 11 for us. You can see this is 11. Okay, so don't get confused whenever you just stop like you're not going to do x plus y first. That is a wrong method. If you're just going to do x plus y, that is, I say 5 plus 3, which is 8. 8 times 2, which is 16, which is wrong. You can see it's actually wrong. Okay, so that body mass is very, very necessary to understand. So if your intention is that you want it to do x plus y by force first, then you just need to put a bracket. Because brackets will make it a higher precedence than this our multiplication. Looking at our board mass again, remember the board mass starts with the bracket b as first. So this will give us the another form answer here, which we've seen already as 16. So you can see this one has given us 16. But by focus on the brackets first, so it added the 3 plus 5 first. So 3 plus 5 will give us 8, and then 8 times 2, which is 16. That's why we get to see the 16 here. So just understand these aspects. Lastly, let me do another program that still looks like this, but this time around I want us to declare I want us to use another function aside from main, like our own user defined function. Don't forget the main is as a default of ints, okay, but it's just that we choose not to write it because by default code blocks know it is int, but some editors might not know, so you just need to put it right just in case. So let's do a user defined function problem that still looks similar to what we have done here. I'm just clearing all of this for now. Let me start with the user defined function at the top. So I'm going to declare the function. Don't forget, always declare your function. And I want it to be, I want to name the function integer add. You can name it whatever you want. You get. Now, in this function, I want to put parameters. Okay, and each of those parameters, I have to declare those parameters also. Or you can also call it arguments. So int x, int y. So I'm declaring both of them as integers. Okay, they're actually different type of data types. So we have been doing integers now. You will still see the rest like the char, the car data type, the double, the floats. I think in the next video you will learn more about the other aspects. Right. Okay, so for now, I want to do addition of integers. Okay, then put our curly brackets. So first thing, we declared the function name with our ints. Then we also declare each of the parameters. So we have two parameters, and if you notice, we separated it by comma. I remember it is in our notes. I talked about it, separating it by comma. That's the parameters. So what I want to do, I want to create a variable which I choose to name the variable results, and I want it to be x plus y. Okay, x plus y. And remember, since this is a variable, you have to make sure you declare any new variable you create. So I'll declare the variable, always declare it at the top. Okay, so I'll declare it as int since I'm dealing with numbers. So I'll declare it as int. Let me just take this down a bit. All right. So lastly, I'm going to return. So I'm going to use the return statement. So return. Now, what am I returning? Now, what this return is doing is that, let me show you. That's my notes. I made mention of something concerning this return. Where is it? Function, aside from function, creation. Okay, a function is used to signify what a function type rather. Remember that our function type here, our user defined function type here is integer. Okay, so a function type is used to signify what type of value a function is going to return after execution, which means anytime I call this function, I call the name of integer add, what it will give me once I call that name is what I'm going to put in this return statement. And what I want it to give me, I want it to give me whatever answer that is within this variable, which we call the results. Okay, so whenever I'm calling integer add, integer underscore add, and I put whatever values, I want it to just give me the results of this calculation that I've put inside here. So that's what this return statement does. So it calls out what it's just a form of specifying to your code what you want it to call out whenever you are mentioning the name outside. I think we are done with this user defined function. Then remember that even if we try to run this, it won't run because our C program always starts and ends with our main. It starts running and stop running with our main. So we can't just do something like this and try to build it. It won't work for us to show errors. So which means I will have to call this function inside my main function. So let's see how to go about that. All right. So first to do that, I can just say integer add. Then that space where we have x and y, then I can choose to put whatever numbers that I want to add. So I can say maybe 5, comma 10. So the 5 here, the first one is taking the x part, the 10 is taking the y part. That's what it means. Okay. So I've called my function inside the main function. Right. So I would like to store this function in a variable. So let me just name that another variable. I want to store it inside here. Okay, it's just for it to look neat in a way. And since I've created a new variable, which means I will have to make sure I declare that variable. So I need to declare it. Okay, so it's an integer. So int data type sum. So I've declared that variable. So I call the function and I stored whatever value or the answer this function gave me inside this variable called sum. So now I'm going to print it out. Okay, so I'll say the addition gives us whatever answer, new line character, that new line character just for new line space. Okay, so I'm going to then put the variable name that I want it to print. So I want it to print this sum for me. All right, so since we're in our main function, I'm going to say return 0. All right, return 0. And usually in users defined function, we hardly use return zero when it comes to user defined function because you actually want it to bring out something that pertains to what is within your block. And yeah, it just reminds me of something again. Remember, I've talked something about statement also. I said each statement ends with semicolon. So all these are like many statements inside. We have 3 statements inside here. Then this curly opening and closing brackets makes it a single statement by the compiler. Okay. So just keep that one at the back of your mind. That was what we're reading um in my jottings there earlier. Right, so if I were to print this, this should give us the addition gives us whatever value our sum is. Okay, and we know that we already called our variable, which is the sum. We call the function integer add. I'll give it 5 and 10, which means this place is 5 and 10. That means x is 5, y is 10. And we've already given it as an addition stuff. So it's going to be 5 plus 10, which give us the results. Okay, so the results will return out inside this our name, whenever we call this name. So it's the answer that is 5 plus 10, which is 15. So this result will bring out 15. Whenever I call integer dash add, then the value to bring out 15. So just like saying this whole thing like this is 15. So you have placed the 15 inside this sum, which is then this sum which we are calling now printf. So if we print this, this should give us 15. So that's the 15 there. All right. So that's just how to go about all of this. Another way of doing this though, even if you don't want to necessarily store your function in a variable name, like we did here using this sum, you can just choose to call it directly inside the printf, just that it will make it look somehow. That's integer add 5, 10. Ensures we will not even need to do this one self at all then. We won't need to do this one self. So if we want this to give us the same answer as the other one, can see it's still the same 15 it gives us. So that first one, I just feel that first one is more understandable in a way, like, so your code will look very readable and comprehensive, all right, and neat. So I think this is all we have for this lesson. So I hope you understand this very well. If you don't understand it, choose to replay the video and watch it again, watch it again, watch it again. That's how to really understand. Then practice with your hands. So practice makes perfect. All right. So have a lovely day. See you in the next class.